Good afternoon. Yeah. Well, first of all, I would like to thank PSS GEODATA for inviting us here to this important BIM conference, international conference. Before we start, I just want to introduce myself and my company. I am Christian Pallaria. I am passionate about technology and of course about BIM technology. I'm using BIM from 2006-07. I'm specialized in BIM technology and in managing projects from an architectural point of view, focusing in coordination with the structural and MEP projects. In 2018, 1 year ago, I took PMP certification, and across my life, I had also the opportunity to be a CEO of a small company, Italian company, which turnover was about 1 million per year. Well, GEODATA is a big company engaged in, since 1984 in the design of underground works. Today it is active in more than 25 countries, and we are specialized in tunneling and infrastructural projects. We supervised and designed the construction of over than 4,000 kilometers of tunnels and more than 3,000 projects worldwide, focused in metro, railways, roads, hydroelectric power plants, geology, and environment. Well, why I am here today and I am not here today? I am not here today to boring you with another boring conference, or at least I hope. And I am here to explain, first of all, how difficult it is dealing with BIM in underground projects. So in a company that develop underground projects and infrastructure projects. Why? First of all, because we don't have a single element located in a specific position. There is a high relationship with the ground. We have to deal with many software that have to be interfaced, and we have to force them, because many times we have to ask to the software to do something that it is not able to do. So we have to program. And above all, we have to deal with people. So the change is very challenging. Many people tell you that why we have to change, why we have to switch to BIM software instead of CAD, because we are able to use CAD. And another important sentence that I heard across last years is BIM will do everything automatically. It is not true. BIM doesn't do anything automatically. You must know the software, you must know the limits of the software, and then BIM can do something automatically, or most of things automatically. Well, going deep to our topic today, I'm going to show you how we realized an hydroelectric power plant project. It's a very complex project, because we have a lot of elements, and each element had to be modeled and designed with different softwares. So this was the first important challenge for us. First of all, we had to realize, using Civil 3D, job site platform, coffer done, and planche pool. Then we switched to another software, Revit and Rhinoceros, to realize the dam, powerhouse, and transformer soul and stop logs. And then, for linear elements, such as tunneling, we had to realize the project using Civil 3D, of course, but then we switched to Dynamo and Python to realize the model inside Revit, just to make and put information inside that. Well, what is Dynamo? Well, it has been presented just a couple of minutes ago, but I would just like to state something more. Dynamo is a visual programming language. It is very simple because there are a lot of nodes, compiled nodes, so we can just choose the nodes that we have to use, connect all nodes with the logical connection laces, and then we can realize the whole automatic process inside our model. But what happens if we don't have the nodes that can do what we have to do? We have to program it. So we have to switch to Python, and we have to realize our custom node. This is a little bit different from Dynamo, because we have to be able to write the code. So we have to know the syntax of the program language. Python is a simple program language, object-oriented, and the most important thing that we can do with Python is enter inside the software with Revit API. So we can break any barrier that is located between us and the software, and we can do whatever we want. Well, how we use Dynamo and Python? We realized a workflow, a code, in which just taking some information, input information from an Excel file, JSON, or MySQL, we can realize the tunnel. So we start with an input data Excel file, for example, in which we add X, Y, Z coordinates that arrive from the alignment and other parameters that are important to model the TBM tunnel. Just reading the coordinates, we are able to recreate the alignment inside Revit and put each ring of the TBM tunnel in the right position and with the right location, with the right rotation, sorry. This is the rotation of the element. Yes, because these colors are not casual. This color represents the correct position of the ring and the correct rotation of that. But moreover, the most important thing is that when we are modeling it, we can also write information inside each ring, such as installation date, ring number, segment position, stationing, the damages that we have found inside the construction, during the constructions, and then also the horizontal deviation and vertical deviation, just to make a comparison between the design and the construction. Well, we can deal with Excel file, JSON file that are located in your local machine. But what about deal with cloud-based file? We can just create our custom node with Python, connecting the model to the database, to a MySQL database, and just write all information inside MySQL, or simply reading that. This is another kind of tunnel. This is not TBM. This is traditional tunnel. The workflow, talking about BIM, is completely the same. Nothing has changed. Only one thing. While in mechanized excavation, we have a ring that has got the same excavation step, because it is prefabricated, so it is the same. In this case, it is not the same. It is changing depending on geological and geotechnical condition. So we have to read the excavation step and design the model depending on that, and also, of course, write that inside the properties. But the most important thing that I would like to state now is that we can write all information we need. So in this case, for example, we wrote the number of supports. So we can have a very low model. So the model is not TV, but it is rich of information. All information are very useful to realize a bill of quantity. When we have to realize the model, so when we have to model each element, each support, in Powerhouse and in the transformer soul. Why? Because there is a lot of interconnection between many caverns, and the only way to check the interference between the supports was to model them. But you can imagine easily that modeling all these elements by hand is crazy. So we realized another Dynamo code. Just clicking on the surface and putting a lot of parameters, X support distance, Y support distance, support length, support radius, material and typology, and so on, we can have our model design it automatically. And above all, we can write inside each element whatever you want, diameter, length, name, typology of the support. All information important, very important for the bill of quantities, which is this. And of course, the model is very important also for exporting the two-dimensional drawings for the client. Well, this is, we have to also to model the turbines. That is a very complex model. We model it using Rhinoceros, and then we import it into Revit, just to have a model that could be informative. So we could put information inside the model using Revit. And then we use Navisworks to manage the project, and also, of course, to realize the bill of quantities of the whole project. Because I told you before that the whole project was realized using many software, not only Revit. So the Navisworks is a common platform that allows us to import all models coming from different softwares. And here we can read whatever we want, above all, quantity of materials. But Navisworks is also important to realize 4D and 5D simulation. We can realize a model connected automatically with the plan, with the Microsoft project plan, giving the connection through specific parameters that we have to decide before the realization of the model. But what I want to show you now is another workflow, which is a little bit different, because we started with the Civil 3D now. We divided the excavation into different portions, and we splitted the total bar of the excavation into these different excavation portion using VBA code inside Excel. So just to show you that there are many ways to achieve an objective. Sorry. Well, I finished my presentation about the hydroelectric power plant, but I would like just to show you something more. So I would like to show you many experiences we had across last years, totally different one from the other, very quickly. This project is located this station is located in Santiago of Chile. This station was built in 2004 with an empty space realized for the future crossline that we had to design just a couple of years ago. In the first instance, we had to realize a survey. You can imagine this is a very complex geometry, so you can imagine that with the traditional CAD survey, it was quite not possible, it was crazy. So we decided to use a laser scan survey, we imported it inside Revit, we modeled the whole station depending on that, and that we were able also to using phases inside Revit. So the gray color is the existing station, the red color is the project, and the yellow color is all demolishing. Well, another experience is about the cut openings. So this is just a portion of the station. In the big station, we had a lot of ducts and a lot of pipelines that intersects many walls, architectural walls. So we had to create void. How we can do that? We use a plugin to do all cut openings, and when the plugin didn't work properly, we realized a dynamo code as always. Well, another important project is a station located in Russia. This is in Russia, in Moscow, sorry. This is a very complex station. We are managing this station from architectural, structural, and MEP point of view. But what I want to show you today about this station is how we realize the structural model and how we imported it inside robot. So this is a very complex structure. These are columns, are not vertical columns. So we had to realize all the project, all the structural model, paying many attention to the analytical model, to the connection with nodes, between nodes, and to the connection between plate elements. And then we imported it inside robot, and then we calculated it. Another experience we had was about the abutment of a bridge and the rebar of that abutment. We are talking about 60 abutment. There were, in this project, there were about 35 bridges, so 60 abutment, very similar between themselves. So we decided to create a prototype, just one family, parametric family, and then we realized the rebar inside that. So at the end, we're just changing the parameters, the thickness of the wall, the height of the wall, the dimension of the foundation. Most rebars, not all, most rebars change it. So I would just like to state what I was talking about before. Not all is automatic. You have to be careful about that. Sophistic is very powerful to create also the shop drawing, so the tiling of rebar. And we had experience also in geological modeling. We are using Leapfrog. We put just all information about the investigation, and Leapfrog is able to interpolate all information and create a stratigraphy. We have just to put our model inside that and to verify all critical points. What we are doing now, and unfortunately I can't show you right now because we are studying that, is a new code that is able to recognize the stratigraphy, recognize the characteristic of that, geological and geotechnic, is able to make to find the intersection between the stratigraphy and the model, and is able to show you what are the critical points. So in this case, it is not very important because this is just a single element. But what about a very long element like an alignment, like a tunnel, like 20 kilometers of tunnel? If there is something that can do for you automatically, is very, very good, right? So finally, our last experience is about design the ring, design the segments of the ring. We realize a plugin inside Inventor. Just putting all information inside the plugin, we can obtain the 3D model as output with all details. I don't know if you can see that, but there are a lot of details here. And of course, we can realize also the two-dimensional drawing for prefabrication. Well, I have finished my presentation about our experiences. I would just like to show you other two topics. The first one is about classifiers. We talk about classifiers in the first step of this presentation. Unfortunately, we didn't use classifiers right now. And this is a huge problem for us, because at the beginning of the project, we usually define the classification with the client. We usually define how to call the family, how to call the parameters, which parameters we need, and so on. So at the end, we can deliver the project, but at the end, only us and our client can read the project. So we are just considering to switch to a standard international classifier in future projects, so right now. And probably we are using COBie standard for next project, which is a big project in which they are asking us to realize a very big project and a high level of development, because they want to use the model for maintenance during operation. And finally, then I have finished, I promise you. Future suggestion. Decision-making, machine learning, and big data. We are talking about big data day by day. Big data are coming, are here, around us, and are coming. And what we can do with big data will come, really. In our core business, we are thinking to use big data and machine learning technology to develop a new decision-making automatic process in tunnel excavation without use empiric solution that we are using right now. Well, I have finished my presentation. I would just like to state one thing more. All things you have seen today have been not done only by me. There is a very huge group, a very huge team behind all this, which is GEODATA. And I would like to thank all my colleagues and all my ex-colleagues to have helped me to do all this and to achieve all these objectives. And of course, thank you so much to everybody of you for your attention.
Спасибо, Кристиан. Спасибо большое.